Thank you. Thanks for having me. Thanks for accommodating my schedule and rescheduling. Um, yeah, thanks for being here. Um, I think not knowing the audience well up front, I've probably chosen a disappointingly surface level view of the work that we do, but hopefully it's quick enough of a jump that where there are some more specific questions, we can dig into details and for those who are excited to talk things through. So I'll tell you a bit first about our lab, and uh, the way I frame this talk, I want to get to a problem that I think of as really sort of a critical near-term problem for us to tackle, and I'm going to call it now the spreading butter on the toast problem, and I'll get to why I think of it this way in a few slides. First, I'll tell you a little bit about our lab. At Cornell, we're the Environment and Livelihoods Modeling Lab with the ELM Lab, where Tan is currently a member. And the work that we do in the lab spans sort of thinking about how it is that people make decisions about the things they want to do with their lives across the spectrum of rural through urban spaces, and then what the consequences of these decisions, maybe responses to new forcings or new policies, interventions might be at scale. And so we invest in trying to develop what I might think of as policy labs, modeling and games toolkits that help us walk through some of these problems, and we've applied them in domains looking at migration, irrigation. We have a project in human-wildlife conflict, all kinds of other fun things. And in particular, the toolkits that we apply are generally behavioral experiments and games to try and tease out what are the ways that people make the decisions that matter for the problem we're speaking of, and then agent-based modeling tools to explore what are the consequences of those at scale. So I'll talk just very briefly about the games that we do. We've been playing games and having fun for, I guess, a little more than a decade now. We use a platform called NetLogo, which is an agent-based modeling platform that also allows us to have devices talk to each other and play multiplayer coordination games. So we started, the very first game we built was something called non-crop share, where we looked at this dilemma of trying to encourage insect-friendly farming and the use of natural enemy services as a pesticide alternative, which is just a challenge because if someone defects and uses pesticide, then everyone's worse off. We played that in Cambodia, Vietnam, and China. We went from there, we adapted that game, sort of reskinned it to look at lethal and non-lethal control problems of pest animal species like lions, elephants, and geese. We played that in Scotland and Tanzania and Gabon. And from there, we developed a whole sort of series of related games looking at land tenure in Kenya, looking at optimal fallowing in shared spaces in Madagascar. We recently published this one looking at the coordinating pasture use among pastoral communities in Ethiopia and Kenya. We have a game looking at willingness to contribute to sort of shared investments through a village savings and loan association that we're playing in Madagascar. Actually, the list of games is too long to kind of dig into each one of them. Current projects include, we have this game called Watergate, where we're looking at problems of sort of upstream and downstream basin conflict resolution in Pakistan. And we have some other planned games in Malawi and Argentina that we're developing. So we're doing a lot of different things across the world. And if you're interested in any of these games in particular, they're all posted on our website, and with reasonable pace, we update where publications are available. The toolkit that we use, as I mentioned, we play in NetLogo, where you can connect. That little device is just your phone, and run a game on one computer and have people kind of talk to that computer via your mobile phone. And what's nice about this system is you can do it anywhere that you can find a place to sit down and be comfortable. You can play these coordination games, and it allows us to move beyond having to bring people to a computer lab or work with students. It just allows the games to function as what we might call like a better boundary object for engaging with resource users. So I'll say a couple of things about what we're doing when we build games. If I'm thinking about people's sort of, well, everyday and along their livelihood resource decision making, we sort of imagine that people have some set of underlying relatively stable preferences, beliefs about things that do change. Like I don't want the same things that I now that I did when I was 10 years old. My preferences have changed over time. All this to say that when we build a game, we're trying to do our best to capture some dimensions of reality so that we have what we might call a valid construct, that the thing that we're measuring in the game is meaningfully related to the thing in the real world that we care about, which is a little bit of a challenge. There's a lot of things going on in the world. It's hard to know whether we've captured everything that matters. And so when we think about what belongs in our game and what doesn't, I often think about it like this. If I can imagine some decision that people are making, and maybe they're choosing between A and B, maybe they're choosing to wear a jacket or not. What we're trying to do is, if you work with me abstractly here and think about this oval here as all the points in my life where it makes sense, say, to like wear a jacket, like it's December, it's freezing, I'm just going to wear a jacket. That space of our life. And then there's sort of the other space of our life where it makes sense to just go out without a jacket. It's August in the Northern Hemisphere. It's hot. I don't need to worry about it. Those aren't parts of people's lives that really want to capture because it's clear what people will do. But in between there's some space where there's a strategic decision that someone needs to make, responding to uncertainty or responding to actions of their peers and coordinating. And those sort of strategic choice situations are what makes its way into our game. And so our job is not to try and simulate everything that's going on in someone's life, but it's to figure out what are the dilemmas that people are facing and what is the specific decision context that within, or the context within they're making a decision, and how can we recreate that as a valid construct in our game. That's our task. So I'm going to set that aside for the moment. I elected not to show a lot of results here, or any results really, but I wanted to talk about the different things that we did. I wanted to turn to agent-based modeling, which I'm guessing you may have heard of. You may even be agent-based modelers yourselves. But so you may know, for instance, that when we build agent-based models, we're building models of individual decision-making agents, making the kinds of decisions that, for instance, we're trying to isolate and learn about when we play our games and do our behavioral experiments. So we're looking at people making driving decisions or deciding who to vote for or whether to invest in a thing or not. And in agent-based models, properties at the system level that we care about emerge out of interactions among these agents and their environment, and are a consequence of what those agents are doing and the sort of heterogeneity often that we see across agents. And so they can be really, really powerful tools where we believe that heterogeneity or differences across agents and the way they interact with each other is important in explaining the outcome that we care about. So differences in political preferences lead to different leaders being elected, for instance, where we're able to simulate how some intervention shifts the way a decision, like a voting decision, is informed. We maybe learn a little bit about what we might want to do if we're trying to shift the way things are governed, as a specific and not current example, not at all. So I'll give you an example. So this is sort of a cartoon output from a modeling tool that we use in our lab called MIDAS. So this is the Migration, Intensification, and Diversification as Adaptive Strategies model. Whenever you build a model, you got to give it a fun acronym, otherwise you'll go nowhere. We've used it in a number of different contexts. This is a specific toy example from Bangladesh. And it's set up to allow us to, where we have access to specific data sets about income, expenditure, climate shocks, whatever it is, answer very specific questions. Like, and in Bangladesh, we examined how we expected coastwise migration to be reshaped by the additional forcing factor of sea level rise in the coming decades under different assumptions about shifts in carbon concentration. So under different RCP scenarios, what did we expect to see? But we're also set up with MIDAS to step back and answer toy questions, to sort of say, well, what if we live in a world where there's an urban space and a rural space? Or what if we experience a general shock to agriculture? Or what if there are several countries and one of them creates a visa restriction, or some of these toy questions that allow us to, in a more general way, walk through and understand the consequences of our assumptions about the way things happen. So we have kind of an applied approach and an explore approach. And in case any of you are interested in using models or using this model in particular, it might be fun to have a more detailed discussion about how we set up MIDAS applications. But it's very generally a tool that allows us to look at how agents in particular places embedded in social networks and participating in different livelihoods opportunities make decisions about what's the best thing for me and where do I want to go. So I probably won't in this talk dig into details about MIDAS, but what I will do is maybe talk a little bit about how we think about models. I often find we'll talk about models in a presentation or a class, and we'll realize later that across our group, people don't have the sort of same shared understanding of what it means when we say model. And it can mean many different things, coming from an economics background or a biology background, or any other space. You probably have different experience with what it means to build a model and use the model. So I would say, to sort of put ourselves on common footing, very generally, often as scientists, we're really trying to answer X, Y questions in most cases. Is this thing X related to Y? Is there a causal relationship where X causes Y? And probably we have some set of observations available to help us make sense of this. And so often what we do where we observe things about the world, that we have bugs in this month and not in this month, or it's cold in this month and not the other, or when water's warmer, it's bigger, or whatever thing we're looking at, we can take those observations and apply some specific set of assumptions about what those observations mean in order to generate data. And I make this point here just to emphasize that data itself is a sort of product of being reorganized through some set of assumptions that make it different than just a set of observations on its own. And then imagining we have some understanding of the system that we care about, perhaps we're able to apply some additional set of assumptions that allow us to take our data set and then maybe try and reproduce our Y outcome. Maybe we have some idea that in our data set, we have a bunch of different, I'm going to call them X variables or independent variables that have some role in predicting Y, and we test that out to see if we can generate some estimate of Y. And I don't want to belabor too much this sort of like walkthrough of working from observations through to outputs, but the point that I'm hoping I can make here is that these little blocks where we're applying assumptions, those blocks of assumptions are what I would think of interchangeably as a model or a theory. And so we use models to transform observations into data, and we use additional models to transform data into outputs or things that we can make use of. And in all of this, we're starting with this very sort of basic set of ingredients. We have questions to inform, we have observations about this thing we care about, and then we are able to make sets of assumptions that come together as theory or models to inform ourselves. So if I can walk away with this definition of models or theories being sort of sets of assumptions that help us to transform observations into something that helps inform our question, that's what we're doing. Whether it's an econometric model or a simulation model or an equilibrium model or a toy model or model car, whatever it is, that's what I feel what we're doing. And in our lab, we spend a lot of time thinking through how can we develop appropriate models. And in the same way, in the games that we work hard to think through what is a valid construct for us to try and recreate, we have to think through what is the appropriate set of theory or model or set of assumptions to help explain our problem. And so what I would say is, building good models is this iterative challenge that is, you're never done and your model's never right, but hopefully over time it's better and better. And it's got a few key steps that I'm going to break up here into what I'll call theory building processes, right? So the creative side of putting ideas together to think, could this explain my problem? And then theory testing processes where we kind of take the scientific method and just hack at things to see what stands and what's left when we're finished. And so I think of establishing problems, stating questions, and then assembling sets of assumptions to inform that question as theory building processes. And then I think of exercises to help demonstrate validity, meaning demonstrate that the set of assumptions we've assembled is appropriate to inform the problem or the question that we've posed. I think of that as sort of the first among our theory testing processes. And then where we're in the case as modelers, where we've been able to put together a model and demonstrate through some exercise how well it fits our problem, we then get to explore and try new things and look at conditions we might not have otherwise been able to observe. And I organize it like this, partly so it makes a fun word, PAVE, but partly because it allows me to sort of demonstrate a few things. I think these are all connective and definitely iterative. So this is one way of rolling out the modeling cycle that, again, never stops. You talk to new people, you collect new observations, you try different things, and you realize your assumptions probably could be different, or you tackle a new challenge and you modify your problem and assumptions. But at any point as a modeler, if you want to describe what you're doing, I think this is a nice pathway to do it. And the reason I organize it this way as PAVE is that this makes a nice chain where as we move from left to right, from problem to assumptions to validity to exploration, we're always moving in a way that everything to the right requires everything to the left to be valid. And by that, I mean, if we don't clearly state a problem or a question, there's no way we can judge whether our set of assumptions is appropriate to put together as a model. If we don't explicitly lay out what our assumptions are, it's impossible for us to judge whether they're valid for informing our problem. And if we don't ever demonstrate how valid our set of assumptions is to our problem, it's not ever going to be possible for us to interpret the results of any free exploration. So they all belong together as sort of part of the model building and demonstration process. And the other key thing to say is we don't always have to make it all the way to the right. I have lots of products that are really just, and you've probably seen products like this in the modeling world yourselves, where people look at the theory, look at what we understand, and outline key questions. So you see wonderful papers that outline, here are core problems, or papers that outline conceptual models, sets of assumptions that they believe are possibly helpful in informing a problem, and they stop there. Moving from left to right, you can do all kinds of cool things, but the key thing to note as modelers is wherever we are missing a stage, we can't go any further. So if anyone finds this interesting, I'm happy to discuss further, but I'll let it go for now, and I'll try and take ourselves from the abstract space and get real for a second. So I've blah, blah, blah for now, 15, 20 minutes about modeling theory. Why is this helpful? Why should we ever care about any of this? So in our lab, taking these things together, good, careful modeling and demonstration of fit to purpose, and games demonstrating construct validity and appropriateness, again, to elicit core dilemmas, we inform questions like, we have some current work looking at this growth in solar irrigation farming in South Asia in particular. Who benefits when we subsidize the installation of solar irrigation systems, and what happens to groundwater as all of a sudden it's so much easier and less expensive to pump water from the ground, as an example. What is it that investments in shared cooled spaces in very warm places can do for shifting heat exposure, public health, congestion, safety? These are the kinds of things that where we can assemble a computational tool and use behavioral experiments to learn about decisions, we can learn a lot. And sort of more generally, ask ourselves, like, what are the kinds of investments that may end up being pro-poor, so really helping to bring up the back and benefit people who are have less access to opportunity, and which won't? And maybe if I can just take a little bit of a detour for a couple of slides, I have a framework that I have found helpful to think about what it means to do pro-poor development, and that I've used in my lab to sort of guide the way myself and our students think about problems. It's a framework that you may or may not be familiar with, and it is Super Mario Kart. So in our lab, we do a lot of sort of Mario Kart based thinking about environmental governance. And this may seem silly. I'm going to look at the participant list and see if we lose people now, but I have a point here. Mario Kart's been around forever. So I played Mario Kart when I was a kid, and it's fancy now. You can play it on your phone. It's really exciting, but it's the same game, and it's been around for decades because it's fun, even when you're terrible. And the reason for this, there's this sort of pro-equity design principle where when you're at the back, your cart, and so that's, yeah, it's your younger siblings, the ones you just destroy, your grandparents, whoever it is, whoever's at the back, they go faster, they get better bonus items that help them better. And that forms this sort of balancing feedback loop that keeps the back of the race pegged relatively closely to the front of the race. So this now, came out in 1992. It's been emulated across the gaming. Any racing game that you play now uses this. It's called rubber banding. There's a big literature on it. It's quite exciting. And the way it works is in the game, Nintendo or whoever makes Mario Kart is able to know who's in the back and know how far away they are from the front. They're able to generate boosts or benefits for those carts for nothing, for free. And importantly, they're able to target those in the back. And that pro-poor targeting of developing some kind of an intervention and apply it in the back, it's really difficult to do in reality. I mean, it's super easy in a game. It's kind of what makes Mario Kart so exciting. But figuring out how to make that work is a challenge. And the reason for this is, I mean, any instrument that you can think of, whether it's a microcredit, or a subsidy or an insurance bundled to a loan or whatever it is, it's going to be relatively easier for someone in the middle or someone in the front to access that thing. And figuring out how we can target things to the back is like the core development challenge. So why do we care about any of this at all? When I think about environmental development and I think about sort of Mario-Kartizing environmental governance, the idea is that where people don't have good options, you're precluding people's capacity to really choose and to be able to make decisions that are good for them and good for the space around them. So you're sort of factoring people out of being able to be good environmental stewards, even if they would choose to be. In agriculture in particular, we got a lot of evidence now accumulated that medium scale, market integrated family farms are this sweet spot of choice and stability and good environmental stewardship. And if we think towards a future where we have these sort of like relatively larger family farms, relatively more resilient family farms, it probably means a different landscape of who's doing farming. And so, first of all, what are the opportunities for people in the future that might not be farming in the way that they are now? That's a pretty core question to think about. And then as well, how do we recreate all of the things that make cities function in the way that they do? So that's sort of the core value proposition of being in cities. You may have, for those of you who are urban planners or have read in the space, have come across this sort of sharing, matching, learning paradigm. The idea that when we're surrounded by more opportunity, we're better able to share in the things that are available. We're better able to find our matches. And this is the thing that's exposed so much more by the world of mobile phones and your access to Twitter and Uber and Tinder or whatever it is, whatever way you're making use of high resolution, high frequency spatial data in cities, you're accessing the sort of core value proposition of cities. How can we bring some of those into rural spaces and sort of shift what our definition of being in a rural space is? And that's what gets me to this thing that I think of as a butter on the toast problem. How is it that we can spread out sort of economic opportunity and urban amenity that we enjoy in urban spaces into rural spaces so that the opportunity set is different? And this is something that's likely is going to play out differently around the world. But broadly, it's a sort of set of questions of like, as these traditional agricultural livelihoods become harder to do or they disappear, what ought future rural economies look like? And depending on where you are, things could be different. It may be that it's rural value chain integration into agricultural production. You have regional culture and pride built up around things that people grow and produce. And so shifting how things are value added and marketed could be one part of it. But also, as I think we probably all experienced a little bit during COVID when, wealthy people flocked out of cities and tried to drag their broadband internet access with them into rural spaces. How much opportunity do we have to sort of create creative spaces, creative jobs, creative economies in rural spaces, different kinds of industries, et cetera? So I pull all this together just to say, I think it's really common. There's a lot of a lot of interest in sort of solving, rural livelihoods problems and rural food systems problems, but sort of linking food systems problems to urban development problems, I think is I don't know, an exciting thing we can do to, unlock new possibilities. And so in our lab, we're sort of asking a lot of questions around, when we look at rural spaces, what does this mean? And over the future, who do we expect will stay? And why is that, as a way to try and understand what might be the kinds of interventions that do well in the future. So I think that's enough from me. Talked for probably too long. I'll stop there. And maybe if I can take any questions, I'm glad to do so. And thanks for your attention.